You know that feeling when you're stuck in a city with terrible traffic, where one little fender bender on some random side street somehow brings the entire downtown area to a grinding halt? Well, that exact same kind of chaos can happen inside our digital worlds. So today, we're going to dive into the blueprint for building a better, smarter network, one that's way less like a traffic jam and a lot more like a well-planned city. Let's get into the architectural plan that keeps our digital lives moving smoothly.
So really, what do a network and a city have in common? It might seem like a weird question, I know, but the answer? It's pretty much everything. Seriously, the principles that make a city work, with its local roads, main arteries, and super fast freeways, are the very same principles that help us create a robust, scalable, and reliable computer network.
And that brings us right to the problem, the digital traffic jam. This is what happens when you have what's called a flat network, where all the devices are just connected randomly with no real structure or plan. Just picture a city with no planning, a tangled, chaotic mess of roads going everywhere and nowhere. In a network like that, one switch goes down and bam, entire departments are suddenly offline. It's just inefficient, a total pain to manage, and an absolute nightmare to troubleshoot. Okay, so to fix this mess, we need a city plan. And in the world of networking, this city plan has a name: the hierarchical model. It's a structured, professional approach that takes us from that tangled chaos and gives us a clear, logical, and really efficient design.
This model, which is pushed by industry giants like Cisco, is all about organization. It works by dividing the whole network into these distinct layers, or tiers, and each one has a very specific job to do. It's like how a city planner wouldn't just build a freeway right through a quiet neighborhood, right? This model makes sure every piece of equipment is in exactly the right place, doing the right job.
So what does this blueprint actually look like? Well, the most common and probably the most robust design is the three-tier model. You can think of it as the ultimate city plan. It's made up of 3 layers: the access layer, the distribution layer, and the core layer. Let's break down what each one does.
All right, first up, we've got the access layer. If our network is a city, then this layer is all the local streets and driveways. It's the part of the network that's physically closest to us, the actual users. This is literally where our computers, our printers, and our phones plug in and get connected to the network.
But this layer does a whole lot more than just connect stuff. It's responsible for delivering data packets to their final destination, providing power over Ethernet to run devices like VoIP phones, and it acts as our first line of security. It does this by separating traffic into what are called virtual LANs, or VLANs, which is basically like creating different digital neighborhoods on the same physical network. This is how you make sure the finance department's data never accidentally bumps into the guest Wi-Fi traffic.
Okay, moving on up, we have the distribution layer. Think of these as the main roads and the busy intersections of our network city. This layer's job is to take all the traffic coming from those local streets, our access layer, and direct it intelligently. It's the crucial link between all of our different neighborhoods and the big freeway.
You can think of this layer as the network's traffic cop. It uses something called access control lists, or ACLs, which are basically digital rulebooks that decide which data can travel where. This is where you enforce policies, route traffic between different VLANs, and, this is super important, provide redundancy. So if one road gets blocked, the distribution layer is smart enough to find another route, no problem. And then, right at the very top, we have the core layer. This is the high-speed freeway. It's the absolute backbone of the entire network, and it has one job, and one job only: to move massive amounts of data across the network as fast as is humanly or, technically possible.
Now notice what's missing here. There are no complex policies, no filtering, no ACLs. Why? Because any hesitation at this level would create a network-wide bottleneck. Putting policies on the core is like putting a stoplight in the middle of a freeway. It just completely defeats the purpose. The core is all about pure, unfiltered speed and reliability. It's the superhighway that connects everything together.
Now, that 3-tier model is fantastic for huge companies, for large enterprises. But what if you're not building a sprawling metropolis? What if you're just building, say, a small town? Not every network needs a massive freeway system, and that's where a really smart adaptation comes into play.
This efficient design is known as the 2-tier, or collapsed core model. It's a super practical and cost-effective design for small to medium-sized businesses. What you're doing, essentially, is taking the functions of that core freeway and the distribution main roads, and you're merging them into a single, powerful layer. This saves you money and complexity without sacrificing that all-important structure.
So the difference between the two models really just comes down to scale and purpose.
The three-tier model, that's built for massive scale and peak performance in big companies, where every single layer has to be specialized. The two-tier model, with its collapsed core, is designed for simplicity and lower cost, which makes it absolutely perfect for smaller networks that still want the benefits of a good hierarchical design.
So why do we go through all this trouble of planning? Well, whether you choose a two-tier or a three-tier design, the payoff is just immense, especially compared to that chaotic flat network we started with.
Let's quickly run through the 5 key advantages. First up, scalability. Your network can grow easily without needing a total redesign. Second, redundancy. With multiple links, if one path fails, traffic just takes another route and everybody stays online. Third is performance. Data flows logically and efficiently, all thanks to that high-speed core. Fourth, simplified management. Trust me, troubleshooting is a breeze because problems get isolated to a specific layer. And fifth, targeted security. You can apply very precise security policies exactly where they make the most sense, like at the distribution layer, without slowing down the core.
At the end of the day, all of these benefits, scalability, redundancy, performance, they all come together to achieve one big goal: to let you design, deploy, and maintain a truly professional internetwork. And it's this structured approach that makes it all possible.
And that brings us to our final thought. I want you to take a look at the digital infrastructure around you. Is it a thoughtfully planned city with clear paths and logical flows? Or is it a tangled mess, just one traffic jam away from total gridlock? The blueprint is right here. It's just a matter of using it.